Now that we have a linked list, we're going to use that linked list to build a hash table. Now, our hash table is not going to be resizable. It'll have a fixed number of buckets. And we also resolve collisions with chaining to a linked list rather than rehashing or any other kind of collision management techniques for hash tables. So this is kind of like the simplest hash table that you could possibly build. So in this case, our hash table, we'll make a structure for the hash table. Um, hash table, whoops, hash table S. Uh, it's going to have, I guess we'll use a bucket count um, macro just to make it official. So we're going to have uh, an array of entries. So this is going to have a struct list s array of pointers. Um, I guess we'll call it entries. These are, or we can call it heads. Let's call it heads because they're the heads of the list for each bucket. Oh, let me use my macro there. Okay, so this is going to be our hash table. We should actually define it after we define the structure, so the compiler will be happy. Okay, now we need to write a function to add to the hash table. So add to hash table, and this is going to take a pointer to the hash table. Whoops, oh no. And it'll take a string to add. And then we will, um, so in order to add to the hash table, we need to figure out what entry this string is going to go to. Now, so basically what we need to do is hash the string. So we're going to take hash, call it h, is the hash of the string. And then that will tell us the entry that it'll go to. So let's write a quick hash function here. Um, if you remember from your data structures class, there's a whole bunch of different ways to hash a string. And we will do the very simplest one. We'll just add up all the characters. So we do str. Oh, well, we'll start our, actually, let's call it total. And then we say for and I equals 0, I is less than, oh, yeah, str of I does not equal 0. Now we can write that as simply this, right? Because if that is 0, it will be false, otherwise it will be true. So we can just do that. So again, this is the same as that. Okay, so I'll leave it like this, just so that it's very clear. But you'll often see them see people omit this part because we just want to exit when str is 0, where str of I is 0. So otherwise, we're going to add to the total, str or total equals or plus str I. Now, there's a couple of things to keep in mind. Car is signed. We don't want it to be signed, so we want to cast it to an unsigned number. So we'll call it unsigned integer or unsigned char. And then we also are looking for something that will give us a bucket. So we'll mod it by the bucket count. Okay? And then at the end, we'll just return the total. So this is the simple hash function that just adds up all the characters of the string. And it'll also give us the bucket count. So we know that we know age will be between 0 and, whoops, and the bucket count, since we're using the mod. Okay, so this will tell us what entry to go to. So we will then say, we know that table heads of age is the head that we want to add to. So we'll want to add to list, right? This is the list. We want to pass the address of that head in, and we want to add the string. Okay, and that is it. We now have added to the hash table. So let's try this out. So now we're going to change this. We're going to start out with a hash table. And we'll call this table. And we want to initialize table to be 0. We want to initialize all those all the heads to be 0. So the easiest way to do that is just to set everything to 0. So we'll just say memset table heads. So at that location, we're going to set that all to 0, and it will be the size of table heads. Okay, so that's going to be the size of this array right here. We're going to initialize that whole array to 0. All right, so that will set up initialize our empty table heads. Oh, and it doesn't like, oh, what doesn't it like about this? Let's see why. Oh, yeah, this is, sorry, I should use the dot operator since the table is not a pointer. Okay, now we can go through. So let's go through and generate our nodes. So we'll say we'll generate 10,000 nodes. And again, we'll say jar buffer and add to hash table, and we'll pass in the table. Okay. Now, you'll note we want to pass in the pointer to the table because we want to change the table itself. We're going to change the list inside the table. So if we don't pass it by pointer, we pass by value, we'll change a copy, but the original one will remain the same, and we want to make sure we change it. So so let's do that, and then let's print out all the buckets. So we need to change this for loop. We'll say for I equals 0. So we're going to go through each bucket. So I is now our bucket index, bucket count, bucket, what did we call it? Bucket count, yeah. I don't know why it didn't autocomplete there. I plus plus. Um, and then I guess at the start of the bucket, we'll just print some dashes just for some separation. And then we'll go through and we'll print the list. And we already have the code to print the list right here. So we'll copy this. Okay, of course, the head now is no longer head. It is table heads of I. Okay, so this should do it. Let's just, yeah. Okay, let's give it a try. Oh, compiler's not happy about something. Oh, it doesn't like. Oh, it's supposed to be equals. Okay, and it's not liking here. Oh, I'm missing the string to add. So I think it's happy now. So let's run it. Let's see. Oh, so right. So we got. This doesn't look. Oh, so there we go. Um, yeah. So we see it's not a very balanced hash table. It turns out our hash function is not very good because simply adding the characters of a string, especially a string with node, where all the characters are mostly the same, it's not going to give us very much diversity in the results of the hash function. But it looks like they're all here. So let's go on. Let's see. It does look like they're all there. Yeah, they're just clustered in some really big buckets. Okay, so it looks like our hash table's working. Now let's see if we can make it thread safe. Okay, so we're gonna run some we're gonna add some threads to make this go faster. So actually, let's run this with time again. We remember before when we ran it with just the list, it was 0.37 seconds. It'll probably be a little bit. Oh, it's about the same time. So we didn't really change much because this add to hash table function does very little. It does the hash, but then it just calls add to list on the relevant head. So not really any big change in um, running time. So let's introduce some threads and see what that does to the runtime.